Hi guys. Okay, so we are going to do chapter 11, acids and bases, and we will be looking at the homework questions 3 and 5, which relate to the naming and writing the formulas. Okay, so chapter 3, name the acids and or the base. So HCl, first of all, it's very important. You should be able to identify whether a particular substance is an acid or a base. So keep this in mind that for the acid, the ionic acids, not the organic acid, but ionic acids, all of them have hydrogens in front. So these guys are all acids. Okay, so that's one piece. Next thing you have to memorize is that the bases. So for the base, it's the, let me get a different color. For the base, it's the hydroxide. So this is the base. Okay, so that's one difference. Next thing is you should recognize the polyatomic ions. You should recognize the metals and the non-metals. So you can clearly see that calcium is a metal. Okay, let me put a different color here. Calcium is a metal. Okay, and you can replace this calcium with any metal. And when you put hydroxide, so the good part with that is when you name it, the metal name remains as it is, unless the metal has like a Roman numeral, and there is, like, for example, lead. +2 state or lead +4 state. Similarly, tin +2 state or +4 state. Similarly, copper +1 state or +2 state. Iron +3 or +2. So those states, those are going to be in Roman numerals. Regardless, whatever the metal is, you write down the name of the metal and then simply put hydroxide. So this becomes calcium hydroxide. And that's the name. Okay, so that ends it. Next thing is, as I said, you need to recognize the polyatomic ions and the nonmetals. So here we see the nonmetal is chlorine. Okay, so besides that, chlorine belongs to the category of halogens. So just expanding this a little bit further. So halogens, X in this case, anytime a nonmetal is attached to a hydrogen, a non-metal, especially halogen, attached to the hydrogen. So in this case, hydrogen will be named as hydro. The non-metal, fluorine, will become FLUOR. Chlorine becomes CHLOR. Bromine becomes BROM. And iodic, iod. Okay, and then all of them are going to end in ICE. So all these, whatever, if they attach with the hydrogen, then their names will shorten like this, but their ending will be, you just have to put IC. So here in this case, this is hydrochloric acid. Okay, so all of them will end in acid and then IC. So that's for the, as far as the non-metals are concerned. So all the non-metals will end in, IC and then acid. So that's one piece. Next is, you see these type of very special like polyatomic ions. Chlorate family, like chlorate, chlorite. These were discovered earlier, but later on we found that chlorine can attach to 4 oxygens also instead of just 3, and can still have a -1 charge. So then this becomes perchlorate. And then later on we found that chlorine can attach to only 1 oxygen atom and can still have a negative charge. So in that case, this becomes hypochlorite, lower than chlorite. Okay, so let me just put these names. So this is the chlorate 8. This is chlorite. And this becomes hypochlorite. Okay, and then this becomes perchlorate. Now, remember that this is perchlorate, so the name is perchloric acid. Perchloric acid. Okay, now, in this case, then the ick, the ending is in ick. Why? Because it's a higher oxidation state. Now let's understand the higher oxidation state a little bit more. So here we have, in this case, let's look at, let me get another color. In this case, you have NO, and X is the number of oxygen atoms, 2 or 3 with a -1 charge. So we commonly hear nitrate, but then there is nitrite also. So this is the polyatomic ion, nitrate, Nitrate, and this is Nitrite. So lower oxidation state, lower is ending in ite, and higher is ending in ate. So what happens then? Then ate and becomes ick, okay? And the lower one, the ite, becomes us. So we will look into this thing in a minute. So this becomes nitrate, nitric acid. This is nitric, ICE, nitric acid. But let's just assume that this was also HNO2. So in that case, this becomes nitrous acid. So a lower oxidation state, less number of oxygens, us, ending is us with respect to that one particular polyatomic ion. So the ending is in us and higher is in ick. So this is higher ick, lower is us. So don't forget that. Similarly, sulfuric acid and sulfurous acid. So if you see, this is the sulfate, this is the sulfate anion, and this is the sulfite. So ITE is going to end in, so ITE and ATE. So similarly here. So this becomes sulfuric acid, SULFURIC, sulfuric acid. Okay, so here is this IC and sulfate. Okay, now similarly, bromate and bromite. Okay, so similarly here, bromate and bromite. So this is the bromate anion, and bromite anion. Okay, so bromite is lower oxidation state and bromate is higher. But here you see, so this becomes bromous acid, BROMOUS, bromous acid. Bromic acid and bromous acid, but bromous is a lower oxidation state, so us. Okay, so that's the that's again, so bromate lower, this is higher. Okay, so this is going to come through practice, and I have given you the worksheet for practicing, and then you can look at for more examples in the book also. Now here they're asking you to write the formula, so it's the same rules. Okay, rubidium hydroxide. Now rubidium is a metal. Okay, and so that you should remember the polyatomic ions, and you should remember the names and the symbols of the metals. So rubidium, and important thing, rubidium, which group in the periodic table rubidium is in? So let me put this here. Rubidium is lithium, sodium, potassium, rubidium, cesium, francium. Rubidium belongs to group 1A. Therefore, rubidium will have +1 charge. Okay, so this is +1 charge here for rubidium. Let me put this here. Rubidium +1 charge, and hydroxide has -1 charge. So both the charges cancel each other, and this just becomes RbOH. Okay, that's the formula. Let's look at lithium hydroxide. Same is the case. Lithium belongs to group 1A. Group 1A, that means it has got +1 charge. So lithium will have +1 charge and OH will have -1 charge. And then the formula becomes LiOH. Okay. Next is the phosphoric acid. Now, phosphoric acid, remember, phosphoric, ICE. So this is where is IC. Remember, it's coming from, it's giving you an indication that this is coming from phosphate, PO4 -3 charge. Okay, so that's like, that is involved. So phosphoric acid has the somewhere phosphoric Ik is a higher oxidation state, and every time it relates to some kind of a polyatomic ion. So hydrogen ion +1 and phosphoric PO4 -3. So in this case, what is happening? Crisscross. So here, this number is going to come here, and this number goes here. So what is the formula now? The formula is H3PO4. So this is the phosphoric acid, H3PO4. Let's put it here, H3PO4. Okay, next, ammonium hydroxide. Now, ammonium is NH4 +1. So again, you have to memorize that ammonium formula, okay? And then comes the next is the hydroxide. Hydroxide is OH -1. Okay, so what will you do now? So here, crisscross, or these cancel each other out. So the formula now is NH4OH. NH4OH. Okay, because these positive, I mean, you can crisscross also if you want, but basically for one, we do not write for one. We do not write when we cross down, cross down subscript, right, for one. So that is why it just cancels out. Okay, so that's one thing. Now let's look at hydrofluoric acid. So remember, hydrofluoric acid, hydrofluoric, hydro is coming from, that means this is going to be in front. Hydrogen will be in front. Hydrofluoric acid. So in this case, we are just looking at hydrogen +1 charge, fluorine coming from fluorine. And so all this connects together, cancels out, or you can crisscross. This comes here, and this comes here, and this becomes HF. Okay, lithium hydroxide. Now, periodic acid. Now remember, per. So here, lithium was a metal here. So periodic acid. So iodate, it's periodate, O4 -1. That's the periodate. And this is the hydrogen ion. Remember, all the acids, all the inorganic acids, hydrogen is going to be in front. Okay. Now, here you see this number is going to come here, and this one comes here. And this is the periodate anion. Okay, it's a polyatomic ion, and then hydrogen. So when that happens, so this is now HiO4. Okay, so that's how you do the naming and writing the formulas. So this was just a small video for the homework questions. However, we have covered extensively in the nomenclature, nomenclature is covered in the lecture. Okay, so just do those more practice from there. All right, thank you.